All right, CUET champions, let's dive into a secret weapon for your organic chemistry section. We're talking about a topic that literally acts like a master key, unlocking some of the toughest conversions you'll face. And that weapon? It's diazonium salts. So let me ask you something right off the bat. Have you ever wondered why it's so easy to stick a chlorine, a bromine, or even a cyanide group onto a benzene ring that has an NH2 group, but it's a huge pain to do it on a plain old benzene ring? What's the trick? What's the magic that makes this possible? Well, the answer to that question is your ticket to some guaranteed marks. Because listen up, this is one of the highest yield topics in your entire CUET syllabus. Seriously, getting this down means you can walk into that exam and solve direct MCQs no problem. So you're definitely going to want to stick around for this. Okay, let's get to it. It's time to forge that master key. And the whole process, the entire magic trick, it all comes down to one special reaction. The diazotization reaction. So what in the world is a diazonium salt? Think of it as a super useful but kind of temporary helper molecule. It's what we call an intermediate. We make it from primary aromatic amines, and its main job is to be a fantastic placeholder, a group that is just dying to leave the benzene ring, making it super easy for other groups to jump on. We'll see exactly why it's so eager to leave in just a minute. Now, how do we actually make one? It's basically a three-step recipe. First, you grab a primary aromatic amine. Aniline is the classic example everyone uses. Second, you react it with something called nitrous acid. Now, here's a super important exam detail. Nitrous acid is really unstable. You can't just buy it in a bottle. So we have to make it in situ. That's a fancy way of saying we make it right there in the flask by mixing sodium nitrite with HCl. And third, and this is the big one, you have to keep the whole thing on ice. And when I say cold, I mean cold. 0 to 5 degrees Celsius. This is totally non-negotiable. Seriously, write this down, highlight it, do whatever you have to do to remember it. This exact temperature range is one of the most common questions they ask, because if you let it get any warmer, well, your diazonium salt just falls apart. And this brings us to a huge point of confusion that CUET loves to test. Primary aromatic amines, like our friend aniline, they form these relatively stable diazonium salts in the cold. But what if you try this with a primary aliphatic amine, one without the benzene ring? Total failure. It decomposes instantly and you just see bubbles of nitrogen gas. This is a classic MCQ trap. All right, so we've forged our master key. Now for the fun part. Let's actually use it to unlock some incredibly powerful and super useful reactions. This is where you'll really see why this little intermediate is such a game changer. First on our list is the famous Sandmeyer reaction. This is your go-to method for adding chlorine, bromine, or cyanide. Now here's the secret sauce. The diazonium part is an amazing leaving group. Why? Because when it leaves, it forms N2, nitrogen gas, which is an incredibly stable molecule. The universe loves stability. So the whole reaction is driven forward by the chance to make this super stable gas. You just add the right copper salt, CuCl, CuBr, or CuCN, and poof, the nitrogen gas bubbles away and your new group is sitting right on the ring. It's a guaranteed question, folks. But what if you want to make phenol? You want an OH group on there. It gets even easier. No fancy copper catalyst needed. You just take your cold diazonium salt solution and warm it up a bit with some water. That same powerful driving force kicks in. That stable nitrogen gas can't wait to leave, and an OH group from the water just takes its place. This hydrolysis is such a simple, elegant way to make phenol. Okay, let's switch things up and get a little colorful with the coupling reaction. This is different. Instead of kicking the diazonium group out, we keep it. It reacts with another aromatic molecule, like phenol or aniline, and they couple together. This makes these big molecules called azo compounds, and they have this cool nitrogen-nitrogen double bond connecting the two rings. This long chain of alternating bonds is what we call a conjugated system, and it's the perfect structure for absorbing visible light. And if a molecule absorbs some light, what does it do? It shows color. This is literally the chemistry behind a huge chunk of the dye industry. So let's just pause and look at this beautiful summary. This slide is pure gold for revision. You can clearly see the path from your starting material to your final product. Copper salts get you your halobenzenes, warm water gets you phenol, and coupling with phenol or aniline gets you a vibrant azo dye. Go ahead, screenshot this, write it down. This is your cheat sheet for all the big-ticket reactions. Okay, need a super simple way to remember that critical temperature condition? Just say this to yourself. Diazo is a 0-degree hero. Don't forget the cold. Go on, say it with me. Diazo is a 0-degree hero. I know it sounds a little silly, but trust me, when you're in that exam hall and the pressure is on, this little phrase is going to save you. All right, you've got the concepts, you've even got a memory trick. Now, let's put it all into practice. It's time to switch into full-on exam mode. We're going to tackle some questions and, more importantly, I'm going to point out the common traps designed to make you lose marks. Listen up. This is important. These are the mistakes I see students make over and over again. Number 1, forgetting the 0 to 5 degree temperature range. We just covered that. Number 2, thinking aliphatic amines work the same way. They don't. Number 3, mixing up the Sandmeyer reaction with other name reactions, and this is a big one, forgetting the copper catalyst is necessary for Sandmeyer. And finally, getting confused between a coupling reaction and a simple substitution. You are not going to make these mistakes. Be aware of them. Okay, question 1. Let's start easy. Diazotization is carried out at... Look at your options. Go ahead and pause right now. Think about it and lock in your answer. Did you get it? The answer is, of course, C, 0 to 5 degrees Celsius. Why? Because our diazonium salts is just too unstable at warmer temperatures. See, our 0-degree hero mnemonic already paying off. Easy marks. Question number 2. Benzene diazonium chloride reacts with CuCl to give. What do we think? You know the drill. Pause now and solve it. And the correct answer is A, chlorobenzene. This is a textbook classic Sandmeyer reaction. You see CuCl, you know you're putting a chlorine on that ring. Simple as that. All right, last practice question, and I'm warning you. This one's a bit of a trap. Primary aliphatic amine with nitrous acid forms what? Read those options very carefully. This tests that key difference we talked about. Pause and make your choice. And the answer is C, nitrogen gas. Did you spot the trap? The key word was aliphatic. Remember, only primary aromatic amines give you that stable salt in the cold. The aliphatic ones just break down and bubble off N2 gas. Don't let them catch you with this on exam day. Fantastic work on those questions. Now, for the final piece of the puzzle, let's boil everything down into your ultimate last-minute revision blueprint. This is what you look at the night before the exam. Okay, let's do this rapid fire. How do we make it? Primary aromatic amine plus nitrous acid. What's the temperature? 0 to 5 degrees, it's a must. What does Sandmeyer give you? Chlorine, bromine, or cyanide. How do you make phenol? Hydrolysis with warm water. And how do you get those cool colors? The coupling reaction gives you azo dyes. Boom. That is the entire topic in a nutshell. So, be honest. How'd you do on those practice questions? Did you go 3 for 3? Let me know. Drop your score in the comments below. It's a great way to see where you stand. And hey, if this breakdown helped you finally conquer diazonium salts, make sure you hit that subscribe button and officially become a CUET champion. We've got plenty more high-yield explainers just like this one coming your way.